let's suppose you stumble across this kind of problem on the SAT subject physics test. You have an object in the gravitational field of the Earth and you throw it at an angle alpha. Now you are asked to find alpha given r and h sub max. Now this problem is quite hard to solve under 48 seconds, and so we are going to take some shortcuts. Now the formula for r is v0 sub squared divided by g times sine of 2 alpha, where v0 is the initial velocity. Now the formula for h sub max is h sub max equals v sub y sub 0 squared divided by 2g. Now v sub y sub 0 is the velocity on the y-axis, the initial velocity on the y-axis. Now, how do we find alpha out of this system right here? Well, we all know that v sub y sub 0 equals v sub 0 times sine of alpha. And so what we're going to do is that we're going to plug this formula here. And we have h max equals v sub 0 squared divided by 2g times sine squared of alpha. Now this equals v sub 0 squared divided by g times sine squared of alpha divided by 2. Now if you look carefully, you'll see that this quantity here is exactly the same as this quantity here. And so we are going to write r in terms of h max using this. And let me just go forward. We have v0 squared divided by g equals 2h max divided by sine square of alpha. And this is from the second formula. And now from the first formula we have v sub 0 squared divided by g equals r divided by sine of 2 alpha. And so these quantities are equal, and which means that these quantities are also equal. And so we have 2h sub max divided by sine square of alpha equals r divided by sine of 2 alpha. Now, if you remember your trig identities, you will know that sine of 2 alpha equals 2 times sine of alpha times cosine of alpha. And I'm going to plug this here. And now we have 2h max divided by sine of alpha times sine of alpha, it's more convenient to write it this way, equals r divided by 2 times sine of alpha times cosine of alpha. Now, one sine of alpha from each term cancels, and I'm just going to rearrange this a bit. We have, I'm going to move this here, we have 4 times h max divided by sine of alpha equals r divided by cosine of alpha. Now I'm going to move r here and sine of alpha here. We have 4h max divided by r equals sine of alpha divided by cosine of alpha. And again, from your trig identities, this quantity here is tangent of alpha. And so we have 4h max divided by r equals tangent of alpha. And I'm just going to take this 4 and put it here, and this is the end formula. H sub max divided by r equals tangent of alpha divided by 4. And so this formula here is very, very helpful, because if you look carefully, you'll see that given r and h sub max, all you have to do to find alpha is to plug these two numbers in this formula. And so then you would go on your calculator and then you compute alpha from tangent of alpha. And so if you skip all of this computation here and go straight to this formula, in other words, if you memorize this formula, then you will be able to solve this problem very, very quickly. And so this is how you solve this under 48 seconds.